So what we got today is a lesson on the ice chart. And so many of you all have been asking me to do this. So I want to go ahead and tell you guys how to make this so simple, okay? So simple. So what we got today deals with the ice chart. And before you guys walked in the building, I played Vanilla Ice. Ice, ice, baby. Because that song reminds me of what we're talking about today. Ice. You're probably wondering, what is ice? Not the ice that you put in your drinks, but it's dealing with chemistry, with chemical equilibrium. I stands for the initial concentration or pressure, while the C stands for what's consumed or changed. And this is where the equation will shift. And it's either going to shift to the left or to the right. And then, of course, your E is the equilibrium. You guys need to know. So you've got this chemical reaction right here that's already balanced, okay? So what they're telling you is that at 25 degrees, the chemical equilibrium of this reaction is 0.90. If a 1.0 liter flask is initially charged with 2.0 moles of carbon monoxide and water, what are the equilibrium concentrations of all species? So you're probably wondering, all right, well, what do I have to do with this? Well, the first thing is, whenever they're talking about concentrations, you want to make sure that you put it in molarity. They told you that each carbon monoxide and water had an equilibrium concentration of 2.0. So right here, we're only dealing with water and carbon monoxide. They told you that it had 2.0 moles in it. Now, 2.0 moles divided by the 1 liter that's in the flask, okay, is to be divided. You have to divide those two numbers because molarity is moles per liter. So 2.0 moles divided by 1 liter, and I should put the 1 here so you all can see that, okay? And now that gives you 2.0 molarity. Now, you're probably saying, all right, well, what do we do with that number? Well, let me back this chart out so y'all can see. We're going to put it in the initial part of our chart. The initial amount of water that they gave us was 2.0 molarity. And that was the number that we just calculated. They also gave us 2.0 molarity of carbon monoxide. Okay? These are your spaces with the arrows, so nothing's going to go here. For hydrogen and carbon dioxide, they did not give you the concentrations of those. So you know what we're going to put there? Zeros. There wasn't anything given there. Now, when you look at the change or the C, what was consumed? What was consumed? Because they told you that you had 2.0 moles of carbon monoxide and water, you're going to put a negative X here, okay? That means you're going to, because something is consuming, you're going to subtract. You're welcome, Fernanda. You're so welcome. You're going to subtract both of those with an X. Because you are consuming, that means you're eating it up. So if I'm making a withdrawal from your account, from your checking account, I'm deducting money. I'm taking it away. Okay? And because we're trying to find the X's here for our hydrogen and carbon dioxide, we're going to put X's over here on this side. Okay? Because we're trying to figure that out. Now, all you're going to do for your E, the equilibrium, y'all know the deal. You're going to add these two columns together. So right here, I'm going to put 2.0 minus X. So I'm basically bringing the I and the C together. I'm going to do the same thing for over here, 2.0 minus X. Now, in this next column, okay, 0 plus X, of course, is going to still give you X. Same thing over here. So far, so good. Now, what we're going to do, we're going to actually bring all of this down so that we can find the equilibrium concentration of all the species, because that's what they're asking us to do. So in order to find the equilibrium concentration of all the species, you've got to do what? We've talked about this before. Products over reactants, okay? Products over reactants. And if you need a refresher on that, I've got 3 videos up right now that deals with this. So now your products, remember, and let me highlight this for you guys so you remember. Your reactants are on the left side. Your products are on the right side. So that means I'm going to say my hydrogen times my carbon dioxide over water and my carbon monoxide. Okay? Now, to fill this part out right here, the KC, the KC and the part that I wrote in red, we're going to refer to this row right here that I'm highlighting. Okay? That I put the little arrow by. So, they gave us in this problem the equilibrium concentration right here of 0.90. So what are we going to do? We're going to plug all that information in here. Okay. So they gave us and I put QC. It's kind of like tomato. Okay. So I put QC, but you can say KEQ as well. They mean the same thing. So now what you're going to do, okay, because they told me that the equilibrium concentration was 0.90, this number up here, I'm going to put that right there, 0.90. That's going to equal. So now my H2 comes from this column right here. That's my X. And my carbon dioxide is also my X. So I'm going to put that on the top row. So that's X times X. Now on the very bottom, I'm going to put my reactants, okay? My reactants for H2O is this row right here. The 2.0 minus X. And the other one, 2.0 minus X. Okay, the 2.0 is what value? That is your water value, the H2O, and your carbon monoxide value. So I'm going to transfer that down here, and that's 2.0 minus X times 2.0 minus X as well. Okay? So what I just did, I pretty much took what H2 and CO2, which was these yellow X boxes here, I put them on the top, and the 2.0 minus X for water and the 2.0 minus X for carbon monoxide are on the bottom. Now, what am I going to do? I'm going to multiply X times X. And that's going to give me X squared. Now, on the bottom, because both of them are the same, 2.0 minus X times 2.0 minus X, I'm going to put 2.0 minus X, and I'm going to square that because they are the same. Just like X times X was the same, 2.0 minus X times 2.0 minus X is also the same. Now, we want to get rid of those squares. And this is real simple to do. Because in this case, when we have the squares, we are going to take the square root of both sides. Okay? We're going to take the square root of both sides. So I'm going to put a square root over the 0.90 and a square root over the X squared. Of both sides, you know what we're going to end up with? The square, matter of fact, let me show y'all. The square root of 0.90 is 0.948. Okay? We're going to write 0.95 just because of the numbers. 0.95 equals X over 2.0 minus X. Remember, when you take the square root of X squared, it just becomes X. When you take the square root of 2.0 minus X, it just becomes 2.0 minus X. Okay? It's like the square goes away. That's the simplest way I can put it. Now, we're going to have to do something. We're going to have to get X by itself. So what am I going to do? I am going to multiply these two together. Okay? Think of it this way. If I told you that D equals M over V, like if I gave you a density formula and I want to find out, well, what's the M? I have to multiply D times V to give me the M. Okay? Just a little FYI. So now, what are we going to do? We're going to multiply. You're going to take that 0.95 and multiply that times 2.0 minus x, and then you're going to have x by itself. Whenever I multiply, so y'all can see this, I'm going to multiply 0.95 times 2.0 minus x. So let's take the first one, 0.95, okay, times 2.0. I get 1.9. So when I multiply these two numbers right here, okay, I get 1.9. So that's 1.9 minus 0.95 times the x, because you got to do the next one and multiply those. It equals x. Now, what are you going to do? The next step, of course, is to do what? We've got to still isolate that. Now, I'm going to add the plus 0.95x to both sides so that I can get the x by itself, okay? So I got 1.9 equals, so this is like 1, like an imaginary 1 right here, okay? So if you think of it this way, you've got that, and let me give y'all the visual in case some of y'all don't see that. You've got 1x, like an imaginary 1 right there, okay? 1 plus 0.95, and that gives you 1.95 x. We're going to divide both sides by 1.95. And you're going to end up with your x in terms of solving for that variable. So your x over here, okay, is going to be equal to this. Let's see. I always forget the 1. Yes, the 1 is important. Even though we say it's understood, sometimes we still have to write it in to make sure that it's truly understood. We're going to go with the first two significant digits, and we get 0.97, okay? 0.97. Now, we're going to plug that in, okay? That number right there, that is our x. So when we go back to the ice chart, we're going to plug that into the x. Right here, when we go back to our ice chart, okay, and we plug in that point, remember I said I was only going to go with the first two significant digits, the 0.97. We're going to plug that in right here. So, okay, so again, right here for water and carbon monoxide, if we just say 2.0 minus our x that we got 1.03 for water and carbon monoxide. Okay, that's it. And for hydrogen and carbon dioxide, that number is 0.97. Okay, so this x right here would be 0.97. That one would be 0.97. If you've enjoyed this video and you want to see more, join us Monday through Thursday, Eastern Standard Time, 12 noon, to learn more about how to do chemistry the easy way with Professor TK the Chemist. Join us on YouTube and TikTok.